Hello everybody, my name is Simon Meckle. I'm the author of Robotmk and welcome to my talk. Synthetic monitoring. You probably wonder about this term because, especially in Germany, we always talked about end-to-end monitoring in the past. Well, the term synthetic monitoring means a little bit more, and it is more common in the whole world, especially in the US. So, what is synthetic monitoring and why is it, especially for you as Checkmk users, important? With Checkmk you can monitor a lot. You're getting thousands of different metrics, and this is all good and makes sense. But this mess of metrics and services doesn't tell you exactly how your end users see your applications, how their end user experience is. And synthetic monitoring tries to give an answer to this question, and it is divided into two disciplines. First, there's application availability and performance monitoring. Available means, do the required services and the application itself respond at all? And how performant are they? How long does it take to get a response from one of these services? And the second discipline is application transaction monitoring. These checks go even deeper and execute a series of actions on the application user interface. So you probably ask now, I can already implement tests for availability and performance with Checkmk. Why do we need synthetic monitoring? Well, this is true, but not really true. There's a little difference. Let me explain. It's correct, with Checkmk you can implement checks for availability and performance. You all know these checks, check HTTP, DNS, FTP and so on. But this is always from the perspective of the monitoring system and not of your end users. And they will access your application in a complete different network path. And probably, depending on the web application, they can receive different versions of the web page depending on their geographical location. There are many more different reasons why the end user experience is quite another one than you are measuring with Checkmk. So synthetic monitoring means to take the viewpoint of your end users and execute actively what they do. So let's step into synthetic monitoring and let's see what it means in general. For AAPM, for availability and performance monitoring, you need to set up the checks. You have to pick up the appropriate checks in your monitoring system, set the parameters one by one. You also have to implement the transactional tests. All these tests have to run somewhere. You have to prepare the machines, you need the Python modules, Python installation, and also some system to trigger these tests. And furthermore, you want to execute these tests from the outside of your network, to be as close to the user as possible. And lastly, your customers are application owners, business lines, management, and so on. They all want nice graphs and dashboards and reports. So we see that here are a lot of things to do, and one of the more complex tasks is probably to develop these transactional tests. In the simplest case, you would start with a simple Python script, which looks like this. You see that in the very first line it uses the Selenium module for Python, and it's a very simple example. It works, but it has no error handling, no reporting, and so on. And you probably are not writing only one of these tests, you're probably writing 30. And the day will come when you recognize that it's a very good idea to keep your code common, to create modules, and so on and so on. And even if you think that this works, don't underestimate the effort to maintain such a product. It will become one of these rabbit holes you wish you never have crawled into. So what's the alternative? Are commercial tools an alternative? They often have a lot of features and a nice UI, but the problem here is that with commercial software, you're heavily bound to the vendor's technology, to their pricing, and to their strategy. Let me give you a current example. This is an email I got from a friend who's working for a big company, international company, located here in Munich. And they have been using a commercial end-to-end monitoring tool for many years. And this is what they got at the end of February. In addition, we will no longer offer our product, blah, blah, blah. We will be happy to help you select suitable alternative solutions. This company has spent a massive amount of money, time, and effort into their end-to-end monitoring solution. And yeah, all based on a proprietary software, which is now history. So one testing tool which is completely independent from any testing technology and vendor is Robot Framework. Let me outline briefly for those of you who don't know Robot Framework what it is. In 2006, Pekka Klerk searched for an answer to the question how a testing tool could look like which is completely independent from any testing technology. And so he developed Robot Framework as a generic test automation framework. And by the way, it was the topic of his master thesis while he was working at Nokia Siemens Networks. And Nokia Siemens Networks allowed him to release it as open source in 2008. It's completely written in Python, open source, has a huge community, and its most outstanding features are the library concept and the keyword-driven approach. Let's talk about the keywords. To make it simple, keywords in Robot Framework abstract Python source code. In Robot Framework, you don't program in Python, you are using keywords, and the keywords then execute the Python code for you. Keywords can be nested like functions in Python programming, for example. They can take arguments and return back values, and so on. And keywords which belong to the same testing technology, like the Selenium keywords, for example, are organized in a library. And Robot Framework doesn't know at all which library you are using. It's completely agnostic about this. It's more like the glue between all these libraries. And there are a lot of libraries, which are all open source. There are libraries for web automation, Windows automation, network protocols, Kubernetes, AWS, Google Cloud, and so on and so on. And for the case that you have a special use case, which is not covered by any of these libraries, you can write your own library in Python. So you see that Robot Framework is a real Swiss Army knife and can do a lot of things for you. The same code as we have seen before in Python could be written in Robot Framework like this. And you probably noticed that this code is much more easy to read and more structured. Everything you see here marked in yellow are the keywords within one test. And everything on the right of the keywords are the arguments. For example, in the case of the Selenium keywords, these are the selectors you need to access the elements on a web page. So from a very high-level perspective, we can say that Robot Framework is a kind of common language between administrators and developers. I know customers where Robot Framework is used in a way that the developers are maintaining the files which contain the keywords and the selectors for web elements to navigate on their web application. And the administrators then simply import these files and use the keywords to write the test. So it's very flexible and a very good approach. So far we have yet only talked about the testing tool, Robot Framework. Testing means to press a button and to get a result. Monitoring means to execute something in regular intervals, get the status and also record the data. I discovered Robot Framework in 2019 and I was searching for an integration into Checkmk and there wasn't any, and so I developed my own, which is called Robotmk. I presented the first prototype of Robotmk at the Robocon conference in Helsinki. I shouldn't have asked the audience who knew Checkmk because hardly any of these robot guys knew Checkmk, but the feedback I got afterwards was very good, and this encouraged me to continue my work on Robotmk. It's available currently for Checkmk 1 and 2, completely open source, and it's used today in many industries, in communication, energy, financials, agency, government, and so on. And it's currently the most downloaded package on the Checkmk Exchange platform. I've got 3 examples for you to show how companies use Robotmk to test their applications. First, the Carl Zeiss AG in Germany uses Robotmk. The manufacturing process for lenses is becoming more and more complex. And this requires individual production. And for this, the Zeiss AG built the webshop system VisuStore, where opticians can configure and order their lenses as they need them. And they are then produced individually. And this underlines the importance of the system, because without the VisuStore software or web application, they don't make any money. And for this, they use Robotmk to test the whole process from the lens configuration and until the ordering process. The test you can see here is completely written with the Playwright library, which can be seen as a kind of alternative to the Selenium library. It's more modern. This test you can see here in the wild it runs completely headless on a Windows system in production, which means the machine is always locked, which is good for security. So for each logical step in this test, you can see here, for example, order review, shape calculation, lens type selection, and so on. There are one service in Checkmk, and behind of each service there is a different responsible team, which is then notified with the ITSM ticket system. The Checkmk UI doesn't represent very nicely the dependencies of these single services, because this is an alphanumeric sort table, and this is why Zeiss has built a nice Naquist map to visualize the steps, and it looks like this. On this Naquist map, they see at a glance how the ordering process is working and if it's okay. In this case, the step lens selection failed, and it only generates one alert, and all the following steps are simply in a stale state. It's just like it should be. Thanks for Tobias Raab from the Zeiss AG. He's very happy that he and his team can see now the ordering process completely through the eyes of the customer. The next example is from the Tech Alliance GmbH here in Munich. Tech Alliance is an automotive aftermarket company and available in more than 140 countries. If you bring your car to the workshop for maintenance, it's very likely that the mechanics there use the Tech Alliance system, which provides the operation manual for your car and allows the mechanic to order the spare parts for your car directly through one single system. And the test you can see here is written with the Selenium library for Robot Framework. It also runs completely headless on a Linux system. And this test replaced an old PHP-based Selenium test suite, which Daniel Schneider from Tech Alliance replaced with Robot Framework. And he implemented and integrated the test with Robotmk into Checkmk. So thanks Daniel Schneider for this example. He migrated all the tests meanwhile, and all the tests are running stable, and he's already thinking about more complex and longer tests. The third and last example is from the Swiss social insurance. It's a document management system which is hosted by the Abraxas AG, Abraxas Informatik AG in Switzerland. You see that this is a very old Windows app, a legacy app, and I have written the test for this app with the Image Horizon library. It looks like this. This library uses small screenshots of fields, of buttons, of desktop elements, and Image Horizon library searches these images on the current desktop and tries to act with keyboard and mouse actions on the found regions, just like a real user. The test you can see here is running for each of the 26 cantons in Switzerland and tries to open the application with a specific user and tries to open 3 different documents each time with different length and size to measure how long it takes to open this document from this canton. Jens Dunkelberg, the monitoring team lead at Abraxas, is very happy that he could replace the old proprietary end-to-end monitoring solution with Robotmk. And at this point, it should be pointed out that most of the features which are currently in Robotmk were funded by Abraxas Informatik AG, so thank you very much for this. So, what are my learnings from 2.5 years of developing Robotmk? I've seen that Robot Framework is a real powerful solution. I could solve every problem with Robot Framework because of its massive libraries and its flexibility. It seems to be a perfect fit, in my opinion, to Checkmk because both systems are available on markets since over 15 years, both open source, both have a strong community with great support, a yearly conference. You should visit the Robocon conference in Helsinki. It's a very, very nice event, also 2 days. So it's a really nice project. And in every proof of concept I had to implement for customers which wanted to evaluate Robot Framework and Robotmk, Robotmk always won against commercial competitors. And this underlined for me again and again in the past that Robot Framework has exactly the right architecture to be future-proof. So, what's the way forward? I've seen more and more that Robotmk has a lot of potential, but on the other hand, it's hard for me to do this as a single-man project. Time is often a problem, of course, and with Abraxas I was lucky that we always found a solution which is appropriate for all customers and not only for one customer, but developing customer-driven is in general not ideal. And to implement the next big steps I have in mind with Robotmk, I would need a deeper integration into Checkmk, and this is simply not possible with pure MKP packages. Tribe 29 discovered a rising demand of customers which need a deeper integration of end-to-end monitoring, of synthetic monitoring into Checkmk. And so we decided for a cooperation to expand Checkmk with an enterprise-ready solution for synthetic monitoring with Robotmk. We analyzed the market during the last months and compared existing commercial SaaS solutions for web monitoring on the market. And we tried to implement 2 concrete web test cases, which we did with these tools. First, we tried to use the Checkmk pricing calculator. You all know it probably. We entered some data and checked the total price coming out. And the second test case was to try to download the free edition of Checkmk. I have to say that in the beginning we were positively surprised. All these tools had a very well-designed user interface, very easy to use and well documented. But gradually we realized that they had a strong focus on easy use cases and usability, and all at the cost of some functionality. And I can say from my own experience that you always start with easy problems. Yeah? The more challenging problems come later on their own. And I would even go so far as to say that within a trial period of 14 days, as most of these tools offer, you are simply not able to discover all the edge cases of your requirements. So For example, one tool wasn't simply able to drag this slider to the right. You know the slider, it sets the number of services you want to order Checkmk. And this tool simply doesn't provide drag and drop. And man, we are in 2022. Drag and drop is a key feature of most modern web applications, and they simply don't support it. Yeah. So it seems that the demand for a clean UI seems to mark some functionality boundary, and in this case, Robot Framework got a full score because of its flexibility and functionality. But to be fair, also Robotmk has some point of improvements, and to find out what we can improve in Robotmk, we asked Checkmk users, we asked those without any end-to-end monitoring solution, we asked those with an end-to-end monitoring solution, and Robotmk users. Regarding the configuration and authoring, we found out that programming can be a real high barrier. The effort to learn a new testing tool must be as slow as possible. And some customers, which already use some end-to-end monitoring tool, had experience with so-called transaction recorders. These are tools which simply record the single clicks you are doing on a web application and record the XPath or CSS selectors to identify the elements you have clicked. It's good for a quick scaffolding, but the selectors you are getting from these tools are not robust enough and precisely enough against later changes on the page. And another problem is that these tools don't generate assertions. An assertion is something you are executing when you want to test if the application has a given state. For example, if I log into an application, I want to see my username in the top right corner. This is an assertion. And a good test case always should contain also assertions to simply check if the application is in a desired state and ready to do the next click. And these assertions are not coming out from transaction recorders. In regards to Robot Framework, we have learned that the mess of different libraries and possibilities simply can overstrain users which are completely new to Robot Framework. Our takeaway here was that we have to improve the authoring process with a low-code UI. It must be more accessible also for non-programmers. We have a similar situation when we talk about the execution of Robot Framework tests. Not all admins have DevOps skills, and it's very hard to install all the test nodes without any automation skills. You have to know some automation tool. Furthermore, administrators, or most of the administrators, know the need for a version control system for their test cases, but Git is often too hard for them. We have also seen in the case of Robotmk that without any automation software, it's almost impossible to build this in a scalable way. So the efforts will grow exponentially if you are doing this without an automation tool. The takeaway here was that we have to improve the test distribution. We must eliminate the efforts for the whole dependency management and the installation and the preparation of the test nodes. And the test execution should be scalable for all users. It should be simple for all users to make this scalable. Let's go to visualization. In general, graphs and dashboards are very important for application owners, and especially log files are often a good starting point if you want to troubleshoot something and to tackle down to a root cause. In regards of Robotmk, we have seen that users, often in the case of Windows test machines, don't rely on a single host. They set up multiple hosts and are running the same test on these machines because of the fact that Windows update reboots, antivirus scan pop-ups, and so on can disturb the running test and mess up the availability data. And they are aggregating all the results with a BI rule to make the results more reliable. The takeaway was that graphs and dashboards must be as informative as possible and tailor-made for the application admins and for management. Log files must be contain as much information as possible, and we have to provide pre-made business intelligence rules. So these were the results from the interviews so far. Let me now be more concrete, what we are planning to improve in RobotMK in the next time. Our roadmap is divided into 2 phases. Phase 1 contains the steps which are more easy to implement and which are a kind of base requirement for the further steps. The first feature we want to implement is parallel test execution. Hands up, RobotMK users who struggled with the total execution runtime for robot framework test. Who knew the problem that the total execution time of all the test suites exceeded the execution interval? Who had problem with this? Yeah, some hands, okay. I want to show you how RobotMK works today. The only mode RobotMK works today is that it's executed asynchronously in a certain interval, for example, 900 seconds, and then it executes all the suites in one big chain. And the execution interval of, for example, 900 seconds must be estimated from the total runtime. It must be always set higher with a certain headroom, and it turned out to be too inflexible. RobotMK provides you a graph which shows you the total execution runtime and how you are approaching the execution interval, but sooner or later the day will come when it fails, and RobotMK can't handle parallel executions of itself. And for that reason, we want to change the execution mode in a way that each suite can have its own execution interval. And this requires that RobotMK executes the suites in different sub-processes. It gets executed every minute, and every minute it decides which suite has to run depending on the temp files containing a certain timestamp. This will require a lot of changes on the plugin side as well as on the Checkmk server side, but it will pave the way for the further improvements we have in mind. The next feature I want to show is that we want a better test deployment and a better dependency management. For those of you who already know and use RobotMK, you perhaps know that the setup of a test node can be a tedious task. You have to think of a bunch of different things. You have to install Python, you have to install the Python modules, you have to think about portability. Perhaps you want to implement a test on your Windows workstation, but they should run on Linux or vice versa. You have to think about third-party binaries. The Selenium WebDriver, for example, is a binary you cannot install with pip install. If you want to use the Playwright library, you need Node.js and NPM modules. So this isn't a pure Python problem. I've already tried to automate this with Ansible, but I'm pretty sure that the result I came out with wouldn't you call an enterprise product, because it would require a lot of Ansible know-how on your side. Instead, I discovered a very cool tool last year, which is called RCC. RCC stands for Robocop Command Line Client. And the company behind RCC, Robocop, allows their customers to run robot framework tests on their container infrastructure. Or to be more general, you can run any code on their infrastructure. And when they founded the company, they had exactly the same question in mind. How can we guarantee that the code which is written on the customer's machine can run reliable on our container environment? And so they developed RCC, which is written in Go, cross-platform, open source. And with RCC, you can create, distribute, and run code in completely isolated environment. You can think of RCC like a kind of virtual env on steroids. It's a very nice technology. It needs only 2 files. You need the RCC binary and 2 YAML files. You need the conda YAML file and the robot YAML file. Conda YAML specifies the dependencies. What should be installed in this environment? And it fetches all the sources from Conda Forge, for example, Python modules and Node.js, compilers, whatever you want. And the robot YAML defines what should be executed when this task should be run. To give you an example or an analogy, if you compare this with a Docker container, the Docker file specifies what should be inside a container image, and the entry point defines what should be executed when the container starts. And with these 2 files and the RCC binary, you're able to produce the same runtime environment on your machine, on the machine of your colleagues, or on the machine where the test should run. There's also an offline installation mode where you can ship a zip file which acts as a local file mirror, and in this case you can also install completely without internet connection, which is very nice. And another nice thing is that these environments are only created newly if the conda YAML hash changes. If you are running 30 tests on a machine which all have the same dependency, for example the Selenium library, you only need 1 environment. And RCC can handle the simultaneous usage of these environments very actively. Compared with classical virtual environments, we can say that RCC has a very clever method to share common files with the environment, and it's very friendly to disk I/O and disk usage. To give you another analogy here, I would say RCC is like OMD for Checkmk. OMD is also optimized for the simultaneous usage of static files in different environments, which are the Checkmk sites. So I've told that our goal is to distribute the tests on complete, fresh, virgin machines. This is not completely true, because this only applies to web applications, where we simply have to start a browser and the application gets loaded from the server into the browser. But if you want to run a legacy Windows application, as we have seen before, you're still in the need to install this application by yourself on the machine. And this is where RCC opens a real nice door for us, because nobody prevents us to execute not only 1, but several tasks. The idea is that Robotmk starts a pre-hook, then runs the test, and then starts a post-hook. The pre-hook could install the dependencies, configure the machine, install the software, then the test runs, and the post-hook could run some cleanup tasks, delete log files. It could even uninstall the application. We have already tested this in a proof of concept, in a prototype with Saltstack. Saltstack is a very famous open source configuration management tool. It's based on Python, and it can run completely masterless, which means we don't need any server connection. Saltstack can operate completely locally, but it's possible with any other tool also. It should be clear that everything you are executing here is completely up to you. So this will never be supported by Robotmk or Tribe29. The most important part, of course, is the Robotmk task, which executes the test. But what you execute before and behind, it's completely up to you. This is only to show how great the possibilities are with RCC. Another planned improvement is the handling of Robot Framework HTML log files, which are produced on every Robot Framework execution. And they should be integrated into Checkmk, and they are integrated in the current version 2.1 beta 5, I think. What you can see here is a small screen recording. You see that the log files of Robotmk are just 1 click away from the service. You can access the last execution log file, as well as the last error log file. And the nice thing about this is that Robot Framework can take screenshots of error situations and embed these images into the log file. And there are also libraries which can record the current screen and embed an animated GIF image. So this is a very cool feature to see critical parts of a test execution and why they have failed. This makes troubleshooting a lot more easier. Now let's go to phase 2. In phase 2, we want to focus on the authoring process of the more simple AAPM, the availability and performance monitoring checks. AAPM should be a real no-code task. We want to make it as simple as possible, and for that, we want to provide a special page or region within Checkmk where you can enter the details of your application you want to monitor. For example, a URL, a port, and so on. We also want to implement and create a special Robot Framework Checkmk keyword library, which contains keywords for all these active checks you already know from Checkmk, check HTTP, DNS, FTP, and so on, but all written in Python as Robot Framework keywords. And from the data you have entered in Checkmk for your application, Checkmk will generate RCC-compatible, pre-configured, self-contained robots, which you can then select in the bakery rule to deploy them on any machine you want to run them on. And this is a big advantage because normally you cannot parameterize a normal agent or a plugin outside. You always need a configuration file and so on. And this is where these robots can really help you to distribute dedicated application checks on every client you want to run them on. For the transactional tests, we are currently evaluating a brand new tool called Automation Studio, which is also developed by Robocop, which you already know. This is a screenshot of this application. You remember that Robocop allows users to run their code on their infrastructure, and they also want it to make it as easy as possible for their users that they can write these robot tests. And for this reason, they have written Automation Studio. It's available for Linux, Windows, and Mac. It's currently in beta, but already looks very promising. You see in this view the bare Robot Framework code. And if you want to write in this way, you're free to do this, but you can use the visual button in the top right corner, and this switches the complete robot code to a more visual mode. It always reminds me on, I think it's called Scratch, the programming languages for kids, which makes programming for kids available. And if you look closer, all the keywords which are provided by the libraries, you can simply drag and drop to the code view. You are assisted by keyword suggestions, variable suggestion, and so on. So it looks very promising, and there's also the possibility that we can provide Automation Studio with pre-made Checkmk templates, for example, for transactional tests or AAPM tests. We are already in discussion with Robocop about that. It's important to point out that you are always free to use either Automation Studio or still Visual Studio Code. With RCC, which I've explained before, we have made the robots platform independent. And now we want to go into scalability. We are planning to execute these robots in cloud-based infrastructure, which then can scale. And for this, we will develop a RobotMK special agent. And the main difference here is that this special agent doesn't contact an agent on a host. It contacts the APIs of infrastructure providers to run the containers, to execute the tests in the container, and to fetch the results from these containers. And cloud providers which would be possible, for example, could be Robocop, perhaps a Tribe29 own infrastructure, perhaps your own Kubernetes cluster scattered around the world, or for smaller companies, perhaps a Docker Swarm instance. The benefits, depending on whatever infrastructure you are choosing, it makes you independent of a dedicated infrastructure hosted by you, and your synthetic monitoring becomes scalable. The last piece we want to integrate is dashboards and graphs. It should be more easy to aggregate all the results from different test nodes, and the dashboards should give a very high-level view of your synthetic monitoring setup, just like you know it from the Kubernetes dashboards, for example. And we want to improve the generation of graphs. Users who already use RobotMK already know the problem that when you insert a test in a current robot file, all the indices change of the metrics and all your performance data are waste. So all in all, these are the milestones we have in front of us and which we want to achieve in the near future. And perhaps you are now interested how we are planning to separate the open source part from the enterprise product. The open source part, RobotMK Core, will include the parallel test execution and the log file integration. You will still write your robot test in Visual Studio Code. And RobotMK Enterprise, in yellow, will include all the improvements in the test creation, visualization, the robot configurator for AAPM, and also RCC and the special agent for the cloud infrastructure providers will be contained. These are the enterprise features. It's way too early before you ask to talk about a pricing model, so simply stay tuned about this. In the end, I'm very happy that Tribe29 and I can shape the further path of RobotMK together, and I'm pretty sure that we can create a great and a well-rounded solution for you, always with one big mission in mind, that the simple things should be simple and the complex things should be possible. This is the end of my presentation. Thank you.